Let's read this question with little patience. F and G are two functions from R to R and they are defined like this. You can see how they are defined. Then these are real numbers and H is another function from R to R which is defined like this. Now you see A, B and C and D are constants used here and everything is in terms of F and G. Okay, so mostly G you see everywhere you have a G, only in here you have an F. Okay, let's get started because we want to match list 1 with list 2. So let's focus on option number first, like P option. P says that only B is 1, everyone else is 0. Okay, so what is your h of x function? If only b is 1, so it is this. Okay, only this. So my h of x is g of x plus g of half minus x. Now I want to see whether this is 1 1 on 2 differentiable, okay, whatever. So let's decode what is h. Okay, so g of x is already given to you. I need to just figure out what is g of half minus x. So let's write it on the side. What is g of half minus x? Very simple. What are you going to do? Instead of x, you're going to write half minus x. So let's write that. Instead of x, you're writing half minus x. Here also, okay, if half minus x lies between 0 and half and 0 otherwise. Okay. Now simplify a little bit. What is this? This is minus 1 and this is plus 1. Cancels out. It's just 2x. Okay, can you simplify this also? Okay, what does it give you? Because if you do a minus half in all the sides, you get this. Then you multiply by a minus 1, inequality gets reversed, okay, as well as the sign, this. Okay, so actually you'll land up in the same interval, like 0 and half, it is 2x, and 0 elsewhere. Now we have to add, okay, g of x, which is this, and g of half minus x, which is this. What happens when you add them? See, domain is the same, x lies between 0 and half. So 1 minus 2x and 2x, that's just 1, right? So what do you get? It's 1 when your x lies between 0 and half. And what else? 0 plus 0 is again 0, right? So 0 otherwise. Okay. Now what is this? You are just having two values, right? It's a discrete function, either 1, which is in this interval, or 0. Okay, so clearly you can see that the range is what? Only two numbers, okay, which is 0 and 1. Okay, now let's look at the option 1, 1. No, so many values are mapping to 1. Onto, again, no, because its codomain is the complete real line. Okay, you are just mapping only 2 points, 0 and 1. Differentiable, no, it's not even continuous. Range is interval 0 1, no. Range is 0 and 1, yes. Okay, so your p is mapping to 5. Perfect. Now let's look at q. Okay, q is dealing with function f. Let's wait for a while because everyone else is dealing with g. Presently we are in flow with g. Okay, so let's get going. I think I will do with s first. Okay, p we have looked at. Let's look at s. Okay, that is also one thing you should learn. Okay, which one to look first? See, it is d is 1. Okay, so what is my h of x if d is 1? You see, it's just g of x. Okay, h of x is just g of x. Okay, can you just quickly draw what is g of x? Yeah, see, this is your g of x, right? In 0 and half, it's a linear function, right? And at 0 what's happening? X is 0, then g is 1. Okay, so you are here. Okay, and when x is half, it is 0. So this is the line which you're getting, and everywhere else it is what? It is 0. Okay, here also it is 0, like this. So now, is it 1 1? No, so many are mapping to only 0. On to, again, no, the complete real line is your codomain. You're mapping only this much. Differentiable, no, it's not even continuous. Okay, range is this. Yes, right? Range is closed interval 0 comma 1 because everyone is getting mapped in this interval. Okay, so this is going to map to 4. Okay, so this map to 4. Now if you are very vigilant, you can clearly see that there is only c option which is p is mapping to 5 and s is mapping to 4. We are done actually with the question. We don't need to look at q and r. Okay, but let's say we want to complete it up. Okay, now let's go to r option because r is only dealing with g. See, c is 1. Okay, c is 1, so my h of x is x minus g of x. Okay, now how is my this function looking like? You have to just subtract the x, right? So I'm writing x minus g of x. Okay, what is that? 1 minus 2x when x lies between 0 and half. Okay, and x minus 0 because otherwise, yeah, x minus g of x. Okay, so x minus g of x, x minus g of x. So what is this function? Very nice. 3x minus 1, okay, when your x lies between 0 and half and 0 elsewhere. Sorry, not 0, x elsewhere. Okay. Now again, it's a very nice simple function. If you want, you can draw it quickly. How does it look like? Just see, 0 and half. At 0, it is what? Minus 1. Okay, so here. At 0, it's minus 1. And at half, how much it is? 3 into 3 by 2 minus 1. That's half. Okay, half, it is half only. So this is my point half. Half, it is taking value half. Okay, so it's looking like that. Okay. Rest, it is what? X. Okay, y is equal to x. How does it look like? Okay, actually it has to be, because half and half, right? It is going to pass through this. Okay, but not here. Okay, it is going to look like that. This is going to continue. Okay, this is y is equal to x. Okay, so this is your graph looking like. I hope you're okay with graphing it up. Now again check 1 1. No, horizontal line does do. It's not 1 1. On to again, no. Actually yes, right? It is mapping everyone. See, all the real lines is getting mapped. Okay, so yes, it is on to. So our option, we said it is on to, because it is not differentiable, because it's not continuous, and of course range is the complete real line. Okay, so yes, so s r is matching to 2, which is correct in C option. You see that? Okay, now the last one. Okay, the last one is the only one which is dealing with your function f. Okay, q option. It's saying that your h of x is just f of x. Okay, because your a is 1, it's just f of x. Okay, and how is your function looking like? See, you have a mod here. Okay, x modulus of x. What is it mod? When x is positive, it is x only. Okay, when x is positive, then mod of x is x. So your function is x squared sine 1 by x. Okay, and they have given you that it is 0 when x is 0, and when x is negative, then your mod of x is how much? Minus x, right? So minus x squared sine 1 by x. Now you see here, if you look here carefully, then it's an even function, right? Because this x is an odd function, and sine 1 by x also is an odd function. Two odd function will make it an even function. Modulus of x is anyways an even function. So this whole thing is an even function. So h of x is an even function. Okay, now is it continuous? Yes, is it continuous? Because you might have seen it is continuous. Okay, because at 0 only you need to check. Okay, at 0 what's happening? At 0, this, okay, this is a bounded function. It lies only between -1 and +1, and this guy is going to 0 at 0. Okay, so limiting value of this is 0. Even this is 0, because this is bounded and this is going to 0. So if you take limit h of x goes to 0, from positive side it is 0, negative side still it is 0, and at 0 anyways it is 0. Okay, so it is continuous at 0. Okay, the only thing we have to check is whether it is differentiable or not. Okay, what do you think? Is it differentiable? Again, only 0 I need to check, right? The derivability of that. How do you do that? You just do limit h goes to 0. I'm trying to figure out what is f prime of 0. Okay, h goes to 0. What do you have? F of 0 plus h minus f of 0 upon h. Let's take in general. Okay, I can do h goes to 0 from positive side or negative side. Let's do in neutral. What are we getting? Because f of 0 plus h is nothing but f of h. F of 0 I know is 0, so it is only this much. Okay, now what is f of h? Actually, let me take the initial definition, x mod x. Okay, because I don't want to bother myself with positive and negative. So I'm going to write h mod h sine 1 by h upon h. Okay, I want to get this limit. This gets cancelled. Okay, now what do you see? Same thing, right? This is a finite thing. Okay, and this is going to 0. So everything is going to 0, right? Finite number times 0 is 0, right? So you are going to 0. So you got the derivative is 0 at 0. So it is actually differentiable at 0. Okay, so yes, this is 3. This is going to 3. H is differentiable at 0, because it is not 1 1, right? Because if you look at the graph, let me just show you the graph also. Okay, this is y is equal to x square, this is minus x square. It is coming somewhere here, and now it is like having so many zeros right here, like this, like this, like this. Okay, the same thing this side, it's an even function. Okay, now you see it's not 1 1, right? Because if you draw a horizontal line, okay, so many are, it is passing through so many points. It is neither onto, because you see after this, okay, there is no pre-image of y. Okay, after this point there is no pre-image of y. Okay, so the range is of course not this, not this, none of the options, just that h is differentiable on r, because everywhere it is, just that at 0 we need to check, and we got the derivative to be 0. Okay, So, so mind you, we were done with the question in first 2 minutes, okay? But we have to just, in order to practice, we have dealt with all the options and we got the option C to be the correct option. Nice question. See you with another one.